Hello! In this video we will look at the ultrasonic distance sensor HC-SR04, how it works and how to use it with an Arduino. This sensor is a cheap and easy to use solution for measuring distances. However, it is heavily affected by the environment and it is advised to use averaging or smoothing on the readings. The sensor has a range of 2 to 400 centimeters with a 3 mm accuracy. It works with an operating voltage of 5 volts and 15 mA current draw. The sensor has 4 terminals: power, trigger, echo and ground. When a 10 microsecond pulse is sent to the trigger terminal, the sensor sends a burst of 8 ultrasound waves at 40,000 Hz. When the state of the echo pin changes, we know the waves have bounced back. We can then calculate the distance to an object as we know the traveling time of the ultrasound waves. From time to time, the measurements will be erratic and contain outliers. We recommend, for example, excluding strange values and calculating an average from the good readings. For the best reliability, the surrounding surfaces should be flat, large enough, and perpendicular to the ultrasonic waves. We are now demonstrating how to use the HC-SR04 with an Arduino. We will both print the measured values to the serial and control an LED with them. To follow along, you will need an Arduino, a breadboard, an HC-SR04 sensor, and some hookup wires. If you want to have visible feedback, you can also hook up an LED. Remember the 220 ohm resistor. First, connect the ultrasonic sensor to the breadboard. Connect the terminals one at a time to the Arduino. Trig to pin 11 and echo to pin 12. Power and ground accordingly. Connect the LED in series with the resistor to pin 9 and ground. Then let's take a look at the code. First, the sensors and LED's pins are defined and modes set. In the loop, we send a 10 microsecond long pulse to the trig pin, which activates the sensor. We use the pulse-in function, which measures the time the echo pin has been in a high state. The echo pin is set to high when the signals are sent. We convert the echo time to centimeters by dividing it by 2 and multiplying it by the speed of sound in centimeters per microsecond. We print the distance to serial as well as control the brightness of the LED with it. That's everything for this video. Thank you for watching and see you in the next one.